Okay, so as you can see here, we have a graph of percent time spent following by average travel speed. So what this is a level of service graph, which basically explains the level of service of a highway. So the level of service of a highway is usually graded by A, B, C, D, or E. I guess basically like in school, you get an A for the best, B, pretty good, C, all right, D, and etc. So every highway is given a grade. And the percent time spent following, the higher percentage it goes, the lower the grade will be, but it will also depend on the average travel speed. So we can move on to an example so you guys can see how level of service works. Okay, so here is a level of service problem, an example. So as you can see, SR 361 is a class 1 2-lane highway in a rolling terrain. An operational analysis is needed for the AM peak hour, during which a two-way count of 1,275 vehicles, including 157 trucks, 2 buses, and no RVs, has been made. 58% of the traffic was headed eastbound. The section of SR 361 of particular interest is 1.9 miles long, with 12-foot lanes and 4-foot shoulders. 4 intersections and 9 driveways are found along the segment. 38% of the segments have no passing zones. A base free flow speed of 55 miles per hour will be used. If the peak hour factor is assumed to be 0.88, what is the level of service if this section of SR 361 during the AM peak? So after going over the problem, we should really probably talk about the given factors. So here you can see that it is a 2-lane highway, class 1, maybe we should underline that too, and a rolling terrain. This seems pretty important. And operational AM peak hour. So the two-way count, which both sides of the highway will be 1,275 vehicles. So we always want to underline our givens just in case we want to go back to it. And there's 157 trucks, 2 buses, and no RVs. And 58% of the traffic was headed eastbound. Okay. And the part where we are interested in the level of service will be 1.9 miles long. And here we have more information of the 12-foot lanes and 4-foot shoulders. And it also informs us that there are 4 intersections and 9 driveways in the 1.9 mile long segment. And 38% we have here has a no passing zone. So we want to keep this in mind as well. And the base free flow speed is 55 miles per hour. Also take that in count. And the peak hour factor is assumed to be 0.88. Want to underline that to find the level of service in this section. Okay, so I'm going to start with this table, and this isn't too important, not for the calculations, so we could ignore that. But we could start here given an input data. So the segment length. So we know we have a segment length of 1.9 miles and shoulder width of 4 feet, lane width 12 feet. So southbound or westbound, this is not important because our problem explains that it's eastbound. So now we move on to the highway class. In the problem explains class 1, so we could check off class 1. Terrian, it had said it was a rolling Terrian, so we could check here. So the two-way hourly volume is the two-way count that we see here, 1275 vehicles. Okay, and the directional split. So the directional split is here in the problem. It says 58% of the traffic was headed eastbound. So therefore, the directional split, as we can see, is 58% of the traffic was headed eastbound. So we can write 58 here, and 100 minus 58% is 42. These are percentages. So the peak at 15 minutes of the volume is not given if you read the problem over. But if you go on one more, we can see that we have a peak hour factor. And this peak hour factor, we can see here that is assumed to be 0.88. So we can write this. Now that we have the peak hour factor, we can see that we have a volume and the V15 goes here, and we could solve for that. But in this case, we won't need the volume at 15, so we'll just skip over it. So going on, the proportion of trucks and buses would be adding the 157 trucks and the 2 buses, and this portion would be adding those 2 together with 157 plus 2 is 159 out of 1275 vehicles. This will give us a decimal of 0.2. So the decimal means it's, if you multiply by 100, that would be 12% of the volume would be trucks and buses. So here, proportion of RVs, the problem gives us that there are no RVs. So we could write a 0 here. Percent no passing zone is also given, which is a 38% of the segment has no passing zone. So you just plug 38 here, which is a percentage. And access points per mile. So here, this is going to be, I'll work this out over here. So it says there are 4 intersections. So say we have our highway, and there are 4 intersections. 1, 2, 3, 4. And 9 driveways are found along the segment. So we would have, say, each of these lines are driveways. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. This is random. It could be wherever, but it doesn't matter. So if we divide this by 1.9 miles, you can see that the units that we will get will be access points per mile. If you divide this, it will turn out to be 8.9. So now we could plug the 8.9 in here. And now we can keep solving using this table. So now we have a base free flow speed, it says here. The base free flow speed is usually the speed limit plus 5, but the problem here gives you that the base free flow speed is 55 miles. So now we could plug in 55 here. And if you go down, here's a FLS. This FLS is given. You can find this on another table. So this other table is given here. And you can see if you look for, it says here exhibit 15.7, and if you see here, it gives you the lane width, shoulder width. So we have a lane width of 12 and a shoulder width 4. This one is less than 4, so we would use this here. Wait, I'm sorry. We would not use this one because less than 12. So we would use the very last one. Equal to or more than 12. We would use this 4. So we would get a 1.3. So you plug that 1.3 in. And here we have another exhibit, FA 15.8. You go to the 15.8. And here it's saying access points per mile, 2 direction. So we have about 8 access point, close to 10. So if it's close to 10, we could just say it's around 2.3. So let's take a guess at that, call it 2.3. So the free flow speed here, we can see that we have actually 4 equations for this. But if you look through these, we already have a base free flow speed, the FLS, and the FA. So just by plugging these 3 answers, we can get our free flow speed. And if you plug that in, we end up getting about 51.2 miles per hour. Now moving on, we calculate the volumes. So the volume for VD would equal volume times directional split. And if we multiply this, we get 739.5. And here, E of T and E of R are both under a table. So if you look under the table, you find out that you get a 1.8 and 1.1. So now that we have this, we solve for FHBD. And looking at this, we can find this by using this formula. So we know the I and the I stands for, you could use either D, or you can see down here that we have an O. So this VD will just be 739 will be plugged into the VI, while the FHVD here, we can see that here we have a FHV. So if you notice, here's an I and here's a D. The I just stands for the D. It could be the D or the O. And if you plug, we have a 1, we have a PT, ET, PR, and ER. So if you see here, we have our ET and ER. And our PT will just be PT, portion of trucks and buses, and PR, which is just 0. So if you plug all those numbers in, we find out that we get 0.94. And here we we want another number from a table, which you go to exhibit 15.9, and you will find that it is 0.98. Okay. So now to find out our lowercase v here, you plug in to this equation. So VI, which is this V, we have that number. Our peak hour factor, which is peak hour factor 0.88, is plugged into here. We have our FHV, which is right here, and our FG, which is right here. You plug all those numbers in, and you come to find that your answer will be 912. Oh, sorry, there's no period there. 912.2. So as you see here, we have the same exact questions, but this time, rather than the directional split, will be the other one, which is 42% rather than 58. So if you plug that in, volume times that, it will be, you'll find to get 535.2. And if you get all these numbers from the tables, and you get 1.8 and 1.1. And using this formula that we already have, these variables, if you plug all that in, we will get 0.91. And going to the table for this, you will go get 0.96. For the V naught, we do the same thing we did here. Plug all the numbers in to this equation. You will find to get 696.6. And most of the calculations are done now. And to find the average travel speed, you will have to first go to the table, get the number for 1515. You will find that it will be 0.8. So now that we have our free flow speed, free flow speed is here. We have this crazy number. We have our VD, we have our VO, and we found our FMP. Now we plug all the numbers in, and you'll find we will get 42 miles per hour. So if you look back to the graph we showed, we know that we have a 42, somewhere around here, average travel time. So the average travel speed is 42 miles per hour. So to find the level of service, we would have to find the percent time spent following. And the percent time spent following will be the same procedure you use for, all the stuff we did here. And if you can see, you know how to solve for your VD. ET, just from the table, FHV, just from this problem, just how we did before. Same thing for this. And for the base, here, you go to the table, find this. Once you have this, you will be able to plug it into this formula. And once you have your BPTSF percent, you can plug into this formula. And to find the FMP, go to this table, find the number. You have your VD, V naught, plug it in, you find the percent time spent following. And the percent time spent following ends up equaling around 60%. So if you see here, we go to 60%, you come here, we're around here. So this segment, the level of service here is graded at D. So it's a fairly alright road to travel in, but not too great. So that is the level of service.